1,000 is invested at the beginning of each year for 10 years. The rate of interest is fixed at 7.5% per year. Interest is compounded annually. Calculate by giving your answer to the nearest dollar. So on question A, we're asked to find how much the first $1,000 is worth at the end of 10 years. So looking at that problem, we know that the initial investment is $1,000, and we know that the interest rate is actually 7.5%. So what this means is that the investment grows by 7.5% from year to year, which would then therefore translate to a ratio of 1.075, which happens to be our R. Now all we have to do is plug everything we know into our geometric sequence formula, and we know it's geometric because looking at the question, we're asked to find the value of the investment at a certain year, which in this case is after 10 years. And do not be fooled by this. Since it's worded after 10 years, or at the end of 10 years, our n actually is 11 and not 10. So now plugging everything back to our formula, un, which is u11, equal to u1, which is the initial investment, in this case is 1,000, times our r, our ratio, which is 1.075, our increase from year to year, to the power of n minus 1, 11 minus 1. Now just solving this should give you an answer of $1,117.24. So that is how much the initial investment of $1,000 will be worth after 11 years, or at the end of 10 years. 1,000 is invested at the beginning of each year for 10 years. The rate of interest is fixed at 7.5% per year. Interest is compounded annually. Calculate giving your answer to the nearest dollar. So in this problem, we're asked to find how much the initial investment of $1,000 will be worth at the end of 10 years. So we know our investment is 1,000, and we know our interest rate is 7.5% per year. So what this means is that the actual investment increases by 7.5% from year to year, which would actually translate to an increase of 1.075, which is therefore our R for this problem. And now, looking for our n, we are told that this is at the end of 10 years. So do not be fooled. N would actually be 11, since the way it's worded, it says at the end of 10 years, which would be 11 years in this case. Now all we do is plug everything back to our formula, which is our geometric sequence. And by the way, we know it's geometric because looking at the question, we're asked to find the value of the investment at a certain point in time. In this case, it's after 10 years. So un, which is 11, u11, equal to u1, which is the initial investment of $1,000, times r, which we know it's 1.075, which is the amount of growth from one year to the other, to the power of n minus 1, which would be 11 minus 1. And if everything is multiplied correctly, we should get a u11 of $2,061. So what this means is that after 11 years, or at the end of 10 years, the initial investment of $1,000 would actually be worth $2,061. Now in part B, we're asked to find after how many years the value of the first $1,000 that were invested will be worth $6,098.34. So in this case, we know that the actual value of the investment is this. And we know it's a geometric sequence because we're trying to find the value after a certain point. So our UN in this case is 6,098.34 equal to U1, which we know is 1,000 as after the initial investment of 1,000, times R, which we know from the previous question that it happens to be 1.075, to the power of n, which we don't know yet, which is the year. We don't know the year, the number of years that have passed since the 1,000 was invested, minus 1. So from here we can simply just divide by the 1,000 in order to make this simpler. So we get rid of this 1,000 by dividing by both sides by 1,000, which would therefore give us 6.09834 equal to 1.075 to the power of n minus 1. Now what we want to do is get rid of this exponent here, so we can use log to do this. We do log 6.09834 34 equal to n minus 1 log 1.075. So now we can simply divide this number by this number in order to isolate the n minus 1. So if we do that, we divide this by this, we're left with n minus 1 equal to 25. And now all we do to solve for the n is add 1 to this side, so n equals 26. So what this means is that after 26 years, the initial investment of $1,000 will be worth $6,098.34 if the interest rate of 7.5% per year remains the way it is. So there you go.